Welcome to GE Critical Power's Power Talks. Today we are going to talk about how modularity can save the power system owner money on maintenance as well as provide improved reliability. We're going to talk about how power system modularity, what it is, how to implement it, and what it gets you. We'll talk about how power modules are connected together and the ability to change a module without powering down the system. We'll also look at the controller used to control and monitor the system and see why independent operation is also important. This is the typical configuration for a high reliability DC power system. AC is converted to DC in what is called a rectifier module and used to directly power the loads and charge the batteries. Because the load is directly connected to the battery, even if the rectifier fails or the AC power fails, the load is still supported by the battery, and there is nothing between battery and the load to go wrong except mechanical connections. To provide an increased level of protection, we can add additional parallel rectifiers to provide an alternate source of load power and battery charge current in case of a rectifier failure. This is called redundancy of power modules within the power system or charger. If the load requires a power of n rectifiers, then redundancy is expressed as n plus 1, n plus 2, etc., allowing for failure of 1, 2, or more rectifiers, respectively. Should a rectifier fail, the connection of the modules to the bus also allows the ability to hot swap modules, removing the failed unit without interruption of power to the battery and load. Similarly, the replacement unit can be plugged directly into the system to restore the full capacity of the system. In a typical redundant power system that we just looked at, there is usually a microprocessor-based system controller. The controller allows the user to control and monitor operation of the system, setting charge voltage, controlling current sharing between modules, and sending data to a remote user. The system should continue to operate in the sense that it will convert power for the load and batteries, even if the controller ceases to communicate with one or all of the rectifier modules, or even should the controller fail completely. In GE systems, the rectifiers do not need communications with the controller to produce power. So whether communications fail or the controller fails, the rectifiers will still work using the most recently received settings. The current sharing may be slightly less accurate, but otherwise, power as usual. The controller configuration or settings can be saved, stored, and uploaded to the unit after replacement, minimizing the effort required to bring the system back to exactly the same state as before the failure. In this presentation, we've looked at how power module replacement saves time and effort in the modular power system. We saw how redundant power modules allow sufficient capacity for power module removal and replacement without affecting the operation of the system. We also saw how the design of the controller to allow independent system operation allows controller replacement with minimal effort, and how copying and uploading a configuration file to the new controller can minimize the setup time of the new unit. Thanks for watching this Power Talk. I hope it's been informative. If you'd like to know more about GE's DC power products and systems, please contact your local GE representative or contact us through our website